All right, good morning, everyone. We've hit the top of the hour. Thank you, everyone, for joining us this week for this week's edition of the Long Coffee Break. My name is Chris Visconti. I'm a sales engineer in the Hydronics and Plumbing Group. And we are very excited today to have Ryan Green with Shark Energy joining us. And he's going to be educating us a bit on wastewater energy recovery and how that pertains to electrification. Ryan, please take it away.
Thanks, Chris. Yeah, so super exciting subject, one that I don't think a lot of people have possibly heard about. But yeah, let's talk about the power of poo, shall we? So a little bit about Shark Energy Systems. We're headquartered in Port Coquitlam, British Columbia, Canada. Founded in 2010, released our first product to the market in 2011, which was our Shark. 2016 came our Piranha, in 19 our Piranha heating and cooling version. We've now got installations in Canada, UK, Australia, and the US, and more really coming into the US very quickly. So looking at this, why would we consider wastewater in the first place? First of all, it's virtually limitless. We've got a very abundant supply. It's flowing underneath almost every major city. And it's also at an optimal source temperature. Everywhere we found in all of our installations across the world, between 55 and 85 degrees is roughly where we're sitting on the wastewater temperature. So it really creates that opportunity for a good source and a good sink. And in that, we're able to get space heating, hot water, by taking energy from wastewater, or space cooling and air conditioning by rejecting energy to wastewater. So of course, when we're heating, we're using heat pumps, electrically powered. We're reducing greenhouse gas emissions, aligning with all these electrification, net zero, all the initiatives that cities are putting out there, as well as when we're space cooling and air conditioning with it. The condenser water temperatures that we're operating at are seeing operating at are also providing demand side management strategies, because the peak cooling loads are lower than they would be using other systems. So really looking at wastewater, what's the value of it? We know we've got flow. We know we've got a delta T, so we know we've got energy. Lucky for us, when we got into it, Department of Energy put together a study that estimated about 350 billion kilowatt hours, or the equivalent of 88 Hoover dams, is put down the drain in the US on an annual basis. So if we're looking at that at a rough average 10 cents a kilowatt hour electricity rate, presents a $35 billion opportunity to kind of look into this and start saying, hey, let's look at what we're putting down the drain, and maybe let's start putting it to use.
So Ryan, obviously wastewater is, seems to be a very valuable resource and largely untapped. How can we take advantage of that as the market trends towards electrification?
Great question, Chris. I think what we're already seeing across the United States in just about every market, whether you're on the West Coast or the East Coast, is some type of market initiative to either outright ban natural gas, or start looking at codes that are going to start limiting or restricting the use of natural gas. I'm a big fan of the saying, the market gets what the market wants. And right now, apparently what the market is kind of trending towards is that electrification of heating and hot water equipment. So that kind of, brought us real strongly into the market with our two products. Again, we've got our Piranha, which is the small to medium capacity wastewater energy recovery. It is a self-contained water-to-water heat pump that's using raw wastewater as its source. So fundamentally, it's made for smaller type applications, multifamily, breweries, distilleries, laundromats, anywhere where they're putting a significant amount of wastewater down the drain, and we have an ability to capture that wastewater before it hits the city sewer. On the Shark side of things, it's a larger capacity wastewater energy transfer system. It itself is not the heat pump. It combines with water source heat pumps. But the Shark, the main difference between it and the Piranha is it can extract energy from or reject energy to wastewater. And then again, what it's doing is it's providing a thermally optimal condenser water loop that water source heat pumps of really any type can connect into. Looking at the Piranha, again, self-contained water-to-water heat pump, 5, 10, 15-ton modules, can be done in parallel. The real magic happens over in the tank side. With the tank here, the little divots here is where we've got the interaction between refrigerant and wastewater. So this is our patented evaporator coil internal to the Piranha. So as the wastewater comes in, that's where we're extracting the heat from the evaporator and then transferring it into the refrigerant gas. So this is also the decoupling of the wastewater from the domestic hot water loop. So, when you're having that conversation with the building owner, developer, engineer, You're not like, oh, well, is my client ever going to be potentially showering in their own poo? No, it's not something that's going to be happening. It's completely decoupled, raw wastewater to refrigerant to domestic hot water. So that, it's just like any water to water heat pump. Again, raw wastewater is our source. Looking at the Piranha one line diagram and kind of how it operationally works. When we get a call for heat, a submersible handling pump in the wastewater tank is going to inject wastewater into the Piranha. The internal tank or evaporator is going to extract the heat from the Piranha or extract the heat from the wastewater. And once that heat has been depleted, we're going to reject that thermally depleted wastewater back to sanitary sewer and then start the process all over again. So the big thing to think about, the big fundamental change here is, again, we're using a heat pump to provide the domestic or to meet the domestic hot water demands of the building. So instead of having a device that's going to create it very quickly, we're going to make that hot water over a long period of time at a low energy or at a high energy efficiency, low energy consumption, and then store it in hot water tanks so that that is what is deployed when the 6 a.m. peak demand comes online and you need to meet those domestic hot water demands. The Shark system, again, for the larger capacity, larger amount of wastewater flows. This is the Shark filter itself. Any range of flows from about 100 to 4,500 GPM each module. Again, these can be mounted in parallel. Really, any amount of wastewater flow that we can find available, we can put enough sharks in parallel to meet that flow and create that energy capacity and energy transfer on the system. The Shark itself, as it arrives on site, is a factory fabricated energy transfer skid. Behind the control panel, there is an industrial grade JWC Muffin Monster macerator. So that's where, as the wastewater comes in, it's going to eat up a lot of the larger solids. That wastewater is then going to go into our Shark filtration unit, where those solids are then removed through a solids handling pump and rejected right back out to the return. And then the cleaner wastewater goes off through the piping valve assembly here and into our plate frame heat exchanger. Plate frame heat exchanger, really nothing too fancy. It's an Alpha Laval wide gap series. We're not looking for a lot of chevrons in there for super tight heat transfer capability. We're just looking for heat transfer capability in general. So this, this heat exchanger arrangement, we've had it in operation for about 11 years. We've yet to have to open one up because we've gotten a call saying, hey, it's clogging up. We need to open this up, figure out what's going on. At about year 8 on one of the systems, we did decide to go ahead and open it up just to kind of curiosity kill the cat type thing. Most thing we found building up in it was honestly dental floss. So not a lot of fouling, heat degradation. It's proved to be a very sufficient and robust system to remove the solids and create that opportunity to provide clean condenser water through that heat exchange process. So yeah, I mean, when we're looking at it as a whole, Shark and water source heat pumps is love. That's really what we're doing. Usually when you're using water source heat pumps, you're using a boiler or tower to provide the heat and the heat rejection, or a ground source heat exchanger that's doing that heat exchange. See, the Shark is one of the is those things replaced. So the Shark now is what's providing. So this pink loop here is really what is the building condenser water loop. So as this goes out of range too high, the Shark's going to reject energy to wastewater. As it goes out of range too low, we're going to inject energy to it. So that's the whole point, is we're going to be providing that temperature maintenance for a condenser water loop in a building, just like a boiler tower or just like a ground heat exchanger would. Oh, so again, when we're doing energy recovery, taking wastewater, putting it into the building or process, we're seeing high COPs, alignment with electrification, reduced and eliminated reliance on natural gas appliances, and wastewater utilities are also starting to look at this as a way to decrease their effluent temperatures into streams and rivers nearby. And then when we're using it as an energy rejection, taking the processor heat and putting it back into wastewater, we're reducing or eliminating that reliance on evaporative cooling towers, the maintenance behind them, and also reducing all that freshwater consumption associated with them. This is an internal picture of one of our Shark filtration units after about 520 million gallons had gone through it. 6 months, 24/7 operation. You can see as the wastewater comes in, the solids go down through the bottom there and are rejected out to the return. And the rest of the screening does a very good job of screening out the wastewater particles and not fouling. So again, we're getting a really good heat transfer capability, not getting a lot of fouling, and maintaining that heat transfer throughout the entire period.
So Ron, you've done a great job of illustrating the technology available from Shark for reclaiming wastewater energy. But how can our design community, apply this to real-world scenarios in projects that they're looking at on a day-to-day basis to take advantage of that?
Certainly. I think so. We're starting to see a lot of stuff coming up in the US, particularly one project actually here in Boulder. It's Boulder Commons 37 unit multifamily apartment complex. They're shooting for a net zero design. So there's no natural gas on site. All the heating, cooling, HVAC, and domestic hot water systems are electrically powered. So when the developers started going into the system and looking at all their options, they quickly realized that doing a net zero building, the domestic hot water, what was driving the load. So when they were comparing the site energy use intensity of all the different devices that could do the domestic hot water electrically, the high COP of the Piranha system, even combined with the electric resistance backup heater, was a 16% decrease on site energy use intensity versus the air source heat pump water heater, which resulted to them, hey, that's less solar panels, that's less battery backup, that's less all these other things that I have to buy to meet my net zero energy demands. So it helps to offset that first cost scenario, and it's something that we frequently talk about with developers of multifamily apartments that are seeking that low, super high efficiency electrically hot water. Other options that we've also installed in was a 150,000 square foot office in Washington, DC. This is for the DC Water headquarters. They had a lift station nearby that they tapped into the lift station and took about 250 GPM of the 10,000 GPM flow available and ran that through a water cooled heat recovery chiller that fed 4-pipe active chilled beams. And then a water source heat pump DOAS was connected to the condenser water loop to provide the ventilation for the building. So, this kind of, again, any type of water source heat pump, if we have a source condenser water loop, we can use that with the Shark system. Whether that's taking the, building wastewater or wastewater nearby, that's really what we've been able to see here. And 2009 operating statistics, so far we've rejected almost 7 million or exchanged almost 7 million BTUs with wastewater over that entire annual period. On a much larger scale, also here locally, is the National Western Center project. It's about 2.5 million square feet of mixed use commercial. About 90% of the heating cooling loads for all those buildings will be met through the wastewater flow. 2-pipe district ambient loop being used, uninsulated HDPE pipe. 2,600 metric tons of CO2 reduction is what they're roughly estimating on this to for the greenhouse gas emissions offsets. And then instead of doing water cooled HVAC systems in each of these buildings, they're able to save potable water by roughly 3.1 million gallons by rejecting that energy primarily to wastewater as opposed to through an evaporative cooling tower. Kind of looking at a one-line diagram, again, as the wastewater is being, either taking energy from it or rejecting energy to, the Shark is maintaining the condenser water loop's temperature and its range. And then inside each building is a heat pump of that building owner's, decision, whatever it's a heat recovery chiller, water source heat pumps. Again, any type of water source heat pump can connect to that ambient loop. And then again, Shark is just maintaining that temperature as, over the year, whether it's needing heat rejection or heat injection. So hopefully through all of this, one thing that we're seeing is when life gives you wastewater, please don't try to make lemonade. It's not going to end well. But yeah, let's make use of it. Buildings are putting wastewater out. We've got lift stations nearby, passing city sewer mains. There's 350 billion kilowatt hours being discarded every year in the US. So it's something that we can start to take a look at and having that conversation early on in the schematic phase and saying, hey, is this something we can tap into? Yes or no? Let's look at it. And, that's really what we're here for. Even more so in Denver, Metro Wastewater has even come out and publicly put out a website and a flyer that's downloadable saying, tap into our wastewater. We want you to do it. They're not charging any fees to do so. And they've come out and openly said, with all the heat they have in their network, they could heat the cities of Arvada and Thornton combined. So they are really actively, openly wanting people to reach out to them, to Long, to Shark, to anybody in that field and say, hey, let's look into tapping into our wastewater system. We want to look at that feasibility and we want to support that notion of it.
So Ryan, with having that being said, with Metro Wastewater on board and this being a viable opportunity here in the Denver area, are there any quote unquote wastewater hotspots that you know of where our engineering community could be looking to tap into?
Oh man, winner, chicken dinner, Chris. Good questions, dude. So yeah, again, they've been really supportive. So they've already provided us even heat maps of all across Denver of where their heat is, how much heat's available, their flows. So right here where they've got the Delgany Common Interceptor, that's where you would notice National Western Center's right above it. We've got River North right here. We've got Spear Boulevard right here. So all these areas run along major interceptors of Metro Wastewater, and they're also in conversations for all the downtown area with Denver Wastewater of doing a similar concept. So both utilities are aware of it and so far are comfortable with it and supporting it. So, next time you've got a project in these types of areas, looking at doing, any type of multi-family development or these types of things, reach out. We can do some damage with wastewater, and let's unlock the power of poo. So with that, thank you all very much. If you have any questions, please do reach out to Long, and they're very capable hands. And I'll leave it back to Chris on that.
Thanks a lot, Ryan. Yeah, if anyone has any questions or would like any more additional info on Shark, please reach out to your Long sales engineer. And be sure to join us next week when Andrew Tobin will be presenting on blender products, mixing where it matters, reduce spending, and optimize AHU performance with the channel blender. And that'll wrap it up. Thanks, everyone, and have a great day.